Hello everyone, welcome to today's class. This is Teacher Simon taking you through Cambridge International AS and A-Level Mathematics Paper 5-3 for May, June 2024 for questions from 4 to 6. Question 4 here is coming from data representation in statistics. They're saying the times taken in seconds by 15 members of each of the two swimming clubs, the penguins and the dolphins, to swim 50 meters are shown in the following table. Then they're given here. And the good thing, they are all arranged in ascending order. Okay, in ascending order, so it simplifies the work. And then they are telling us to draw a back-to-back stem and leaf diagram to represent this information with penguins on the left side. So if you put the penguins on the right side, you will be crossed. Okay, now what do we need to know when we are drawing a stem and leaf diagram? First of all, the figures on the leaves. Okay, the figures on the leaves, because we have something like this. One is going to be this way, and then the one this way. So the figures on the leaves must align vertically. Are they in one line? Are they under each other? That is number one. Number two, they must increase from the stem. So the ones on the right, they increase going this way. The ones this way, they increase going this way. And then the figures on the stem must increase downwards, like this. And then we must also put a scale to represent the data. So the scale says it all. Okay, because if we have, let's say, numbers which are decimals, we don't put the decimal points on the stem and leaf diagram. If they are big diagrams they are big numbers in thousands, in hundreds, we can leave it out and we just write two figures just. Okay, let's say this one was 35,000, something like that. When you are drawing in the stem and leaf diagram, you are only going to write 35, and then in the key, you now say maybe 3/5. That one represents 35, then you add on the 1,000. You see that? So you don't write those big values here. We must have just two figures that we put on the stem and leaf diagram. Now, let's draw our stem and leaf. So I'm going to have dolphins on the right. So I can write here dolphins. And then penguins. Like that. So we can see that numbers are starting from 30. 30s, like that. Then we have 40s, we have 50s, we have 60s, and then 70s. So meaning we are going to write a 3 here, then a 4, we have a 5, we have a 6, then we have a 7. Okay, this is dolphins. Now, for dolphins, we are having 36 only. So I'll write a 6 here. Then when we go to 40, there is 1, 3, 8, 9, 9. Okay, 1, 3, 8, 1, 3, 8, 9, 9. Then next we go to 50s, 50, 1, 4, 5, 6. Okay, then when we put all of those, we shall have a 0, then a 1, a 4, a 6, and a 6. Okay, then 60s, we have only these ones. So 0, 1, 4, 0, 1, 4. Make sure that the figures align vertically. Okay, then 70s, we have 71, so I'll put it under that. Then we can go to the penguins. Penguins for 30s, we have 5 and 9. So I'll write the 5 here, then the 9 here. Okay, then 40s, we have 42, 44, 45, 45, 48. These ones here. So I will have 2, then there is 4, there is 45, 45, then 48. Okay, then we go to the 50s. We have 56, 58, 59, those ones there. So meaning I can have a 0, a 6, 8, and then a 9. They must be in that increasing order. And then 60s, we have these ones, 1, 6, 8. So I put 1, 6, then 8. Okay, and then 72. So I will put 2 here. And then after that, I'm going to put my key. Okay, without the key, you lose a mark. A key has its own mark. So the key, I can just pick a number. Let's say something like this here. Just pick a number, one number in here, and then pick a number this way and a number this way. Okay, as simple as that. So I'm going to pick 2 stroke 4 stroke 1. Then I can say represents. Then I read the left one first, 40, then 2, like that. So 42 seconds. So since this was time for swimming, right? 2 swimming clubs, times taken. So that is 42 seconds for penguins. And okay, and then 41. So write 41 seconds for dolphins. Now you make sure that even the values that you put here, this one here is different from this one here. Okay, you don't put the same value like this way, like this is 050. Okay, pick distinctive values so that when you are writing here, they are separate. Okay, so just like that. The diagram shows a box and whisker plot representing the times for the penguins. Part B, on the same diagram, draw a box and whisker plot to represent the times for the dolphins. A box and whisker plot just uses 5 values. The lowest value is where this one is starting from, and then where the box is starting from, that is the lower quartile. The line within the box is the median, and then the upper quartile, that is where the box ends, and then where the whisker ends here is the highest value. So it uses those 5 values. Now we shall go to the dolphins, but then we need to find the median. Okay, for the dolphins, median is going to be, since there are 15 values, that means we are going to remain with one value in the middle when we cross from the extremes. Okay, and when we cross from the extremes, you just need to get, let's say I'm having A, B, C, D, E. You can see that these are 5. It's an odd number. So when I cross from the extremes, 1 is remaining in the middle. You see that? But this is the third value. You see that? The third value out of the 5. But this 3 comes from 5 plus 1 divided by 2, right? So that means I will just get my 15. Okay, I add a 1 first, then I divide by 2. So it will be that 8th value. So then we shall go there and then put it. We get it from our diagram. How about the Q1? A quarter, lower quartile. So it's a quarter of the 15 plus 1. So 16 divided by 4, that is 4th. So this one will be the 4th value. And then the upper quartile, Q3, 3 over 4. A quarter is that number which divides the given distribution into 4 equal parts. So this one will be 12, the 12th value. Okay, now we want 8th, that is for median, then 4th for Q1, and then 12th for Q3. I can use this stem and leaf diagram. I can use this data, it is already arranged. So 1, 2, 3, 4, 5, 6, 7, 8. That is 51. Okay, so 51 is what I'm going to take as the median. 51, and then Q1 and Q3. Q1, that is the 4th value. 1, 2, 3, 4. So it is 48. Q1 is 48. Then how about Q3, which is the 12th value? This is 15, 14, 13, 12 will be here, 60. This one is 48 seconds, and then this one is 60. So these ones are the ones that I'm going to here. Let's plot them. We have median 51. So 51. I will draw this one like this. That is 51. And then 48. 48 is here. Then there is 60, which is here. That is actually our box. It contains the 3 lower quartile, median, and the upper quartile. Then the highest for dolphins, and then the lowest, what are they? The smallest is 36, the highest is 71. So 36 is just here. Can make it a smaller one, just like the way the other one was done. And then, but usually we can put something long like that, and also this one long, and then we connect just like that. But I'm going to copy what they have done, so a smaller one, and then the other one is 71. So 71 is just here. I just put that. Actually, for this one, for the highest and the lowest, you always balance them, just like this one was put. You don't put here, it has to be balanced, because this one has to be in the middle. This line here has to be in the middle of the box that you're drawing here. Okay, now I'm going to now connect this to that and this to that. So that will be the box and whisker plot for the dolphins. You also write it there, because this one was labeled penguins. Why don't you label yours? So we have something like that. And then they are saying, hence, for part C, state one difference between the distributions of the times for penguins and the dolphins. When we are comparing the distributions, we use the median and the interquartile range. So let's check the interquartile range for penguins. Okay, you get the upper quartile minus the lower quartile. So the upper quartile for penguins, it is here. This is 61. The lower quartile is here. That is 44. So 61 minus 44. 61 minus 44. This one gives us a 17. Okay. And then how about the interquartile range for the dolphins? Because we have seen this is 60, then minus the 48. This one gives us 12. So this one is bigger than this. And you can see the boxes. This one is longer than this one here. So meaning the values of times for penguins vary more. They are more spread compared to the values for the dolphins. Okay. So they have a higher interquartile range. So when I'm comparing, I will say, because this is about the times taken to swim. So times taken by penguins. The penguins are more spread. You can say are more spread, are more varied, okay, compared to those of dolphins. See? But then when we look at median, okay, because the other comparison can be on median, then we say on average, these ones are faster than the other. If you are fast, that means you take very little time. You get it? So when you look at these two, this one, the median is 50. This one, the median is 51. These ones are so close together. So we cannot use that as a comparison, okay? Though 51 is bigger than 50, but it is a very small margin. It has to be like, imagine has to be like a 3, 4, 5, like that. Then you can say that these ones are faster than the others, okay? So we shall give this one as our comparison. Number 5, Salah decides to attempt the crossword puzzle in his newspaper each day. The probability that he will complete the puzzle on any given day is 0.65, independent of the other days. That means it can either be a binomial or a geometric distribution, because the probabilities, the events are independent and the experiment is repeated. Okay. Then part A, find the probability that Salah completes the puzzle for the first time on the 5th day. For the first time on the 5th day. This means this is a geometric distribution. Okay, this is a geometric distribution. Why is it a geometric distribution? Because n isn't fixed. The number of times the experiment is done isn't known. They just said on the 5th time. You see that? So we need to find our P, which is 0.65. That means our Q is going to be 0.35. So if this person gets the success on the 5th time, that means they have been failing for the last 4. So we shall get Q power 4. And then they succeed here on the 5th one. So we shall have 0.35, then power 4, then times 0.65. So altogether, what do we get? 0.35 power 4 times 0.65. This one gives us 9.75 times 10 to the power negative 3, which I can write as 0.00, then 9, but to 3 significant figures, it will be 0.00, then 975. 0.00975. That is to 3 significant figures. Remember, 0 is not a significant figure unless it is in between other figures. So now here we shall begin from the 9. That would be the first significant figure. Okay, so that is our answer. Part B, find the probability that Salah completes the puzzle for the second time on the 5th day. Completes the puzzle for the second time on the 5th day. That means we can have 1, 2, 3, 4, 5. So on the 5th time, that is where this person receives the success. Okay, so meaning here, this person can get the success on the 1st time, maybe on the 2nd time, or on the 3rd time, or on the 4th time. So I'm going to treat this one as a binomial here. So when I'm finding the probability here, I'm going to look out for that probability where I'm having 4 successes. I mean, 1 success and 3 failures. So I'm treating this one here as a binomial to save time. Okay, so out of the 4 times the experiment is done here, only 1 is a success. The probability of a success is 0.65, then power 1. Then failing is 3 times, so I'll power this with the 3. But then I'll multiply by the 0.65 here. Okay, in other words, you can say there is winning once and then failing 3 times. But the winning can be here, 1 can be here, can be here, or can be here. So those are 4 cases. Okay, so that's why we have 4 combination 1, which is a 4. You see, which is a 4. So after getting 3 times you failing, then 1 time you're succeeding, it appears 4 times here. So that is why we put that combination. So altogether, what does it give us? 4 times 0.65. I'm going to put it to the power of 2. Okay, because there is also this other last one here. Then times 0.35 power 3. So that is 0.0725 to 3 significant figures. 0.0725, 3 significant figures. That is that. Then part C, find the probability that Salah completes the puzzle fewer than 5 times in a week. Now the number of times this one is done is known, so this becomes a binomial. Okay, since n is known or fixed, comma, this is a binomial distribution. Binomial distribution. The number of times is 7 days. Okay, Now, probability of x less than, because they say fewer than, this one is going to be equal to, we get probability of x is equal to 0, then 1, 2, 3, and 4. Those are the ones which are below 5. But that one is going to be hectic. Since 5 isn't included, why don't I say 1 minus the probability from 5 and above? You see that? So we have 1, then here it is probability of x is equal to 5, then probability of x which is equal to 6, and then here probability of x which is equal to 7, like that. Now, what do we get here? I can substitute here, and then I do everything on the calculator. So we shall have 7 here, combination 5. The success is appearing those 5 times. 0.65 power 5, then 0.35 will be power 2. Remember, when you add these powers, you get that n. So 7, then combination 6, 0.65 to the power of 6, then 0.35 to the power of 1, and then 7, combination 7, which is a 1, times 0.65 power 7, and then times 0.35, it has to be power 0, which is also 1 here. Okay, and then what do we get? So I'm going to put everything on the calculator. Okay, 7 combination, let me just put everything like in bracket like this, 7 combination 5, then times 0.65 power 5, then times 0.35 squared, close the brackets. Then I go to another one, 7 combination 6, and then times 0.65 power 6, then times 0.35, close the brackets. Then the last one, 7 combination 7 is 1, so I will just put 0.65 power 7, because even 0.35 power 0 is 1. So altogether, I get 0.5 and the rest of those figures. But then I have to subtract this one from a 1, okay? So I'll say 1 minus that answer. So it gives me 0.468 to 3 significant figures. 0.468 to 3 significant figures. Part D, use a suitable approximation to find a probability that Sarah completes the puzzle more than 50 times in a period of 84 days. The moment they say use a suitable approximation, this is approximating a binomial to the normal. Okay, and the justification for this, we always look out for NP and NQ. So N is 84, the P is 0.65. Okay, and then 84 times 0.65. So what do we get when we multiply these ones? Because you can be asked to justify your approximation. So I would say 84 times 0.65. This one is 54.6. Then how about 84 times 0.35? This one is 29.4. So this is 29.4, and this is 54.6. All of these ones are greater than 5. So the assumption is that if NP and NQ are greater than 5, then we can approximate the binomial to the normal. So the approximation, if they ask for the justification, you say NP and NQ are greater than 5. Therefore, the approximation is valid. Now, why are we approximating this binomial to the normal? If they say more than 50 times in a period of 84, that means you're going to say 51, 52, 53, 54, up to 84. It becomes so hectic. Okay, now we go to the normal distribution, but for the normal distribution, we must know the mean and the standard deviation. But we use this one of the binomial. Okay, so mean is going to be equal to NP, which we have seen up there that it is 84 times 0.65, which gives us 54.16. And then standard deviation, which is root of variance, and variance is given as NPQ. These ones are even given in the list of formulae. You can check out for them. So this one is going to be 84 times 0.65 times 0.35. So what does this one give us? 84 times 0.65 times 0.35. I usually take that one there. I don't put the square root. I use the exact root of 19.11. Now, after finding the mean and standard deviation, we are supposed to carry out what we call continuity corrections. So in the previous videos, I've already said if it is greater than, you add a 0.5. Okay, if it is greater than or equal, then you subtract a 0.5. If it is less than, you subtract a 0.5. If it is less than or equal, you add a 0.5. In the videos that I did before, they are there. So the probability of x greater than 50, okay, maybe just to show you where it comes from, we have a 50 here, and then there is a 51, then there is a 49 here, but there is a 49.5 here, and then there is a 50.5 here. Now, this one here, when we round off the values here, they will all give us the 50, except this one, because this one will now take it to a 51. Okay, so this is the lower bound for 50, this is the upper bound for 50. Okay, now when we round off here, they are telling us that when we round off those figures, you have to get something which is bigger than 50, and of course it has to be from here. We are supposed to use this upper bound and the lower bound when we are solving this. So you can see that when you round off this 50.5, you'll get a 51, which is bigger than the 50. Okay, so that means I'm going to begin from here. So we shall say that here we are approximating the probability of z x then greater than the 50.5. Okay, now why are we doing this? Because we are moving from discrete data to continuous data. Normal distribution deals with continuous data, and for the continuity between the intervals, then we have to get the class boundaries. So 50 has the boundaries of 49.5 and then the 50.5. You see that? Now we standardize this. This is probability of z greater than, remember we have already said z is equal to x minus mu over the standard deviation. So this is 50.5 minus the mean we have gotten, which is 54.6, over the standard deviation, which is root of 19.11. So we can put all of this together in the calculator and we get the answer straight away. So we can come to mode, then we put start, which is option 3, then we press SC, then press shift, then 1, then 5 for distribution. And this is greater than, which is for R. So I put 3. Now I'm going to write this thing here, 50.5. Okay, let me write here 50.5 minus 46, I mean 44, sorry, 54.6. Then we divide by the square root of 19.11. Okay, and I close the bracket, so it will give me that answer. But the three significant figures, I will write 0.826. 0.826, three significant figures. If you want, you can use the table. Okay, so you get whatever you're getting here, but write it to 3 decimal places, because from the table we write up to 3 decimal places. Then after that, you will say 1 minus, because if this one is for greater than and you are this side, then it has to be 1 minus the less than, because the one for the less than is the one which is given in the table. Okay, so that is that. Question 6 is coming from Combinatorics, or Permutations and Combinations, part A. How many different arrangements are there of the 9 letters in the word recorders? So if they are 9, then I'll have 9 factorial. Okay, are there letters which are repeating. We have arrow here, and arrow here. So there are 3 of them. That means I'll have 3 factorial. And then we also have is. There are 2. So I will multiply by 2 factorial. So when I put this in the calculator, what do I get altogether? 9 factorial. Then we divide by 3 factorial multiplied by 2 factorial. So it is 30240. 30, then 240. Part B. How many different arrangements are there of the 9 letters in the word recorders in which there is an E at the beginning, an E at the end, and the 3 R's are not all together? Now, my sample space is from when the E's are at each end. So I will begin from there. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I put an E here. I kill that position. An E here. Kill that position. Okay. Then my sample space is at each end and no other restriction. Okay, that is my sample space from which I'm picking. Now, we have killed 2 out of the 9. That means we are having 7. So this will be 7 factorial to arrange here. But there are 3 repeating R's there. So I will also put 3 factorial down there because of the 3 R's. Okay. Then I can also have the E's at each end. Okay. At each end. And the 3 R's are together. Okay. I can consider when they are together, then after I subtract, because in the arrangement here, the R's can be together or not together. So I again have 1, 2, 3, 4, 5, 6, 7, 8, 9. Put an E here, kill that position. Put an E here, kill that position. So here we have the 3 R's together, R, R, and R, like that. Then this one is going to be one group. It is going to be like one letter. So this is now 1, 2, 3, 4, 5. Those 2 are all shifting every time together. So we are going to have, here we are going to have 5 factorial. Okay, 5 factorial, because these ones are repeating. I would have multiplied by 3 factorial because there are 3 R's here. But again, these R's are all identical. So I will divide by 3 factorial again. It's the same for these 2 E's that are this way. I'll multiply by 2 factorial because one can be here, one can be here. But still, I will have to divide by that 2 factorial because they are in a line and they are repeating. You see that? So we just write 5 factorial just like that. Now that means when the E's are at each end and the 3 R's are not together, so that means we shall get the other sample space we are picking from, then minus these ones when they are together. So then what do we get? 7 factorial. Then I divide by 3 factorial. Then subtract 5 factorial. I get 720. 720 as my answer. Then lastly, the 9 letters of the word recorders are divided at random into 2 groups, a group of 5 letters and a group of 4 letters. Part C, find the probability that the 3 R's are in the same group. The 3 R's are in the same group. Now, I can consider a group of 5. 1, 2, 3, 4, 5. Then 1, 2, 3, 4. Okay? So the 3 R's are in the same group. That means if you pull out the 3 from the 9, you are remaining with 6. So you just need 2 to put here. And this is a selection. They are just groups. So order doesn't matter. We are not arranging here. So here we are using combinations. Okay. So here you have two positions. So you will get 6, then combination 2. You just want 2 to fill up this. And then the 4 which are remaining, you put them this side. So 4 combination 4. Okay. Then we can also have 1, 2, 3, 4, 5. Then 1, 2, 3, 4. The 3 R's can be here. Okay. Now, if the 3 R's are here, remember this is not permutation. We are not arranging them. So that means out of the other 6 which are remaining, you only need 1. So this will be 6 combination 1. And then the remaining 5s, you will put them here. So this means that our probability is going to be equal to, so we have this one here, which is 6 combination 2. Then I say times 4 combination 4. Okay. It is the same. By the way, you can put the 3 R's here, and then you say out of the 6, I can say 6 combination 4. Then the remaining 2, you say 2 combination 2. It's the same thing. You get the same answer. 6 combination 4 is the same as 6 combination 2. Then I will also add this one. 6 combination 1. Then times 5 combination 5. This one is also the same as saying the 6 that I'm remaining with, let me first put them in here. So 6 combination, then 5. Then the one that is remaining, you say 1 combination 1 here. So you see, 6 combination 5 is the same as 6 combination 1. Now, here we are going to have over, because this is probability. So what is the sample space? The sample space is in one group, out of the 9, put there 5. It doesn't matter which one. And then the next group, the remaining ones, put them there. So 4 combination 4. Or this one can be out of the 9, put 4. Okay. Then the remaining 5, put them in the other. This one is the same thing as this. Okay. So now we can put all of this and we get the answer. So 6 combination 2, that is 6 times 5, then divide by 2, that is 15. So 15, of course, 4 combination 1 is a 1. And then here, 6 combination 1 is a 1. Is a 6. 6. And then times 1. Then down here, what is 9 combination 5? 9 combination 5. That is 126. So 126, of course, times 1. So altogether, up there we have 15 plus 6, which is 21 over 126. Okay, 21 out of 126. Can it be simplified? Let's check. 21 out of 126. Yes, 1 over 6. So I can write that simplified one. 1 over 6. So this has been it for this part 2 of the paper. Thank you so much for watching. May God bless you. If you find the content very helpful to you, kindly like, share, and even subscribe. See you in the next video.